Hey everybody, welcome to an edition of the unit circle, and this video is only going to introduce you to the unit circle. So I have just placed a blank unit circle on this video, and we're just going to talk about it for a while. So this has the potential to be a quite lengthy video because there is a lot to talk about when we're working with the unit circle. So basically, the unit circle is a whole bunch of angles in a circular pattern. By now, you should have already been drawing angles in standard position and are comfortable with that. So if you can draw angles in standard position, the unit circle is a whole bunch of those, but they're all based on special right triangles 30, 60, 90, and 45, 45, 90. So there's a couple of very important things you need to know about the unit circle. The values are going to be the same for x and y going all the way around, whether you're in degrees or radians. So we have it all marked out for you going all the way around. You do not have to memorize this in any way once you get to evaluating. And when I say by memorizing, I'm talking about the entire unit circle. If you want to memorize just the first quadrant, that would be helpful to you in terms of time. But I'm going to show you where everything comes from. The first thing you need to know is on a unit circle, your radius is always going to be equal to 1. So we can mark off 4 of those coordinates right now. This guy is going to be 1, 0. And obviously this will be 0, 1. Over here we have -1, 0. And down here we have 0, -1. So those were easy ones. But now we need to start talking about all of the other coordinates. And again, we can get all of these from the quadrant number 1. And they all come from special right triangles. So let's go find the first one at 30 degrees. So if you go back to geometry when you learned about 30, 60, 90 triangles, it had some sort of a pattern. Now, teachers teach this in different ways. I always said we had a short side √3, and 2 times the short side. That's how I taught it. However you learned it is fine. Now, in terms of a reference angle being 30 degrees, you have to remember what I just told you. The hypotenuse, or the radius, is always 1. So 2s is equal to 1. So to find s, we would just have 2s is equal to 1, so s is equal to 1/2. So the opposite side is 1/2. And going up, that's our y coordinate. So we know that our y coordinate is going to be 1/2. But then we have s√3, so we know s is 1/2. So s√3 would be 1/2 √3, which we can just write as the square root of 3 over 2. So our horizontal direction is the square root of 3 over 2. So our coordinate is x, y. So we have the square root of 3 over 2, 1/2. And that is the coordinate at 30 degrees, or pi over 6. Another thing you should think about is, in terms of trigonometry, sine is opposite over hypotenuse. So that would be 1/2 over 1, which is just 1/2. And cosine is adjacent over the hypotenuse, so that would be √3 over 2 over 1, which is still just √3 over 2. So another very important thing that you need to know about the unit circle is our coordinates x, y represent cosine, sine. So nice and easy that it's alphabetical to keep that in mind when you're working with it. So we're going to make this unit circle, or this special right triangle, go away so we can talk about the next one. And then we're going to bring it back. So our next coordinate will be 45 degrees. So if we're thinking about 45 degrees, we have our 45, 45, 90 right triangle. And again, the hypotenuse, also known as the radius in this situation, is 1. But this time we have a reference angle of 45. So these coordinates are going to be the same. Now again, however you learned it back in the day, doesn't bother me. I taught it is we have a leg, another leg, because they are legs of an isosceles triangle, and then we have the leg root 2. However you learned it is fine. So the leg root 2 side is equal to 1. So if we divide both sides by the square root of 2 and rationalize our denominator, our legs are equal to the square root of 2 over 2. So both of these sides are root 2 over 2. So that means this coordinate over here is going to be root 2 over 2, comma, root 2 over 2. So again, we are just explaining right now where everything comes from. In another video, you're going to learn how to use it. So the last coordinate we're going to talk about is 60 degrees. Now this is going to be really easy to show you because we've already talked about 30 degrees. So if we were to just redraw this last coordinate, we still have our radius of 1, which is going to be the hypotenuse, but the only thing that we've done different is change the 30 and the 60. So it's still our s root 3, and our 2s. So the only thing we did was flip-flop the opposite and the adjacent. So if this is still 1, this is still 1/2, and this is still root 3 over 2. So our x direction is now 1/2, and our vertical is still root 3 over 2. So the 30 and 60s just flip-flop. So this guy over here is just going to be 1/2, comma, root 3 over 2. All right, so that's where the coordinates come from. They come from special right triangles. So do you have to memorize this going around the entire circle? As I said, no, you don't have to memorize this entire unit circle. I'm going to show you in the next video how to evaluate just by using reference angles. So if you know how to draw an angle in standard position, it's going to be pretty easy to work with. So let me just tell you one other thing. And we know that we have cosine and sine on the unit circle, so you might be wondering where tangent is. Well, tangent is equal to sine divided by cosine. So every single one of these coordinates also has a tangent value. How do we find them? Well, tangent is y divided by x, because remember, cosine is x, sine is y. So we just have to do y divided by x for all of these. So we'll go get our tangent values right now and write them off to the side. So y divided by x, so 0 divided by 1 is 0. 1 divided by 0, we can't divide by 0, so this is actually undefined. And over here, we have y divided by x. So we have 1/2, and we're going to multiply by the reciprocal because that's the same as, dividing fractions. And of course, those guys cancel, and we have 1 divided by the square root of 3, but we cannot have that, so we rationalize our denominator, and we get the square root of 3 over 3. Next one, we have root 2 over 2 divided by root 2 over 2. So that's the square root of 2 over 2 times the reciprocal, 2 over root 2. As you can see, everything just cancels. The answer is 1. So the tangent at 45 degrees is 1. Finally, the last one, we have the square root of 3 over 2 times the reciprocal, 2 over 1. Those cancel. The tangent is just the square root of 3. Okay? So again, no memorizing. If you know how to work with special right triangles, this is not that bad. Okay, so how do we get everything else on this unit circle? Well, it's all based on reference angles. So let's think about what we have. In quadrant 1, both our x value is positive and our y value is positive. And of course, a positive divided by a positive is still positive for the tangent value. Let's go into quadrant 2. In quadrant 2, we have a negative x value and a positive y value. And a positive divided by a negative will give us a negative tangent value. When we get to quadrant 3, both our x and y are negative. So a negative divided by a negative will give us a positive. So tangent is positive again in quadrant 3. Finally, quadrant 4, our x value is positive, but we are in negative y land. So that becomes positive negative, and negative divided by a positive will give us a negative. So in quadrant 1, you can see everything's positive. That's because x is positive, y is positive, positive divided by positive is positive, so we're good. But in every other quadrant, only one of them is positive. So we have sine is positive, tangent is positive, and cosine is positive. You'll see a funny little thing from time to time that says all students take calculus. That just tells you which one is positive. So in this one, all of them. This one's sine, this one tangent, this one is cosine, listing which ones are positive. But again, if you just think about negative divided by positive and negative divided by negative, stuff like that, it's pretty simple. Just make sure you are familiar with x and y. Okay, so let's talk. How do we get some of these other points? Now, this video is long enough already, and I'm not going to take another 10 minutes to show you how we get every single one of these coordinates, so we're just going to pick a couple, and I'm going to show you how to get them. So why don't we go all the way to 210 degrees, which we also know is 7 pi over 6. How would we find that coordinate? Well, the reference angle of 210 is 30 degrees away from that x-axis. So the reference angle is 30. So all you have to do is copy the coordinates of 30 degrees. The only thing is you have to think about we're in negative land. So this is actually negative square root of 3 over 2, comma, negative 1/2. And of course, negative divided by a negative is positive, so our tangent value is still positive square root of 3 over 3. Done. That's how we get the coordinate at 210 degrees. And again, we're just using reference angles. Let's go all the way to 315 degrees, which is also negative 45 degrees. We're going to find this coordinate now. And this is 45 degrees away. So our reference angle of 315 is 45. So we just copy the 45 coordinate. So that's going to be a positive x, negative y. So this is the square root of 2 over 2, comma, negative square root of 2 over 2. And of course, a negative divided by a positive is negative, so our tangent value is a negative 1. Okay? Finally, we'll do one more so we can use the 60 degree reference angle. So we'll go to 120. 120 is 60 degrees away from the x-axis, so our reference angle is 60 degrees. So we would just copy our 60 degree coordinate, which is 1/2, comma, square root of 3 over 2, but x is negative over here. So this is a negative 1/2, comma, positive square root of 3 over 2. And of course, a tangent value, positive divided by a negative, would give us a negative square root of 3. Okay, so again, this video can go much longer if we find every single coordinate, but there's no need. If you know the first quadrant, everything should be simple. You just have to know the first quadrant and how to draw an angle in standard position and find a reference angle. If you can do that, you're golden. All right, so that's your introduction to the unit circle. This is Longo and I'm out. See you, bye.